What is up, guys? Today we're going to be talking about making games in Unreal Engine 5. So the first thing we're going to do is go ahead and go through the installation process. So the first thing you have to do is you have to download the Epic Games Launcher, and if you just go ahead and search for download Unreal Engine, then it'll take you to a nice page where you can find all of the instructions that you need to download it. And yeah, like I said, the first step is downloading the Unreal Engine launcher. So if we go ahead and download that, you can see it installs here. And then once we have it installed, you can do this on Mac or Windows. We can go ahead and run it. And you'll see there's three options here on the left. And the one we want, obviously, is the Unreal Engine option, which is where you can see there's a whole bunch of different content, but what we want to do is go to the library, and you won't have an engine version yet, so you can install the latest version, which is 5.3.2, and you can just click plus 5.3.2 and then go ahead and click install. Now, once you've installed it, all of your versions will show up here. So you can use an older version if you prefer. They have versions all the way back to somewhere in like the 3-point-something range, I believe. So if you want to stick with an older version for producing a game for a longer period of time, you can do that as well. Now, your projects will show up in this second section here, which is the My Project section. And as you can see here, I have a project here, and then all of your assets, which you get on the marketplace, this tab here, will show up down here. So as you can see, I've got quite a few of those, and you can use those assets in any of your projects. So let's go ahead and launch it. And because obviously we're going to be doing some programming with it, we also need a tool for programming. So the tool I recommend is called Visual Studio Code. And it's just a programming IDE, kind of like the Arduino IDE, which we've obviously been using a lot, but it supports a lot of different languages, including C++, which is what Unreal Engine uses, and it has some really nice integration features with Unreal Engine and Git if you want to use it for source control. So it's just really useful for that. So if you just search for download VS Code, that's what it's called for short, you can just click on the first link and download it for whatever your platform is. And then we can link it to Unreal in just a second once Unreal boots up. So you can see this is the Unreal Project browser, and this is what you can see. You have the projects here, all of your current projects, but you can also go and create from a whole bunch of different presets. So you can see there's lots of different uses for Unreal Engine beyond just games, like visual effects and simulation and stuff like that, but we're going to be using it to program games. So let's go ahead and select the first person template, and we'll call it I'm going to call it a tutorial project, and then we want to make sure to select this C++ option here so that it goes ahead and sets up stuff so that we can program more easily. You can also check the starter content box, and it'll go ahead and put some extra free default assets in there, just like some textures and stuff that you can use for prototyping, just to make it a little bit nicer than a gray box environment like this. So it can take a couple minutes to create the project, and typically the first time you boot up a project, after a while, it will take quite a while to boot up, because what Unreal does is it compiles all of the shaders, which there are thousands of shaders for all of the different materials. Like you can see here in this image, we have this grid material, this blue material, the sky, the clouds. So it has to compile the shaders for all of those materials the first time, and then it caches most of that information so that when you run it the second time, it doesn't have to do all of that work. And sometimes if you use one of the template projects, it'll have it pre-compiled, so it doesn't have to do all that work either. And you can see it's gone ahead and opened up VS Code, but that's because I've already linked it. By default, it may not be linked for you. So if we go to Unreal Editor, Preferences, then we can go to Source Code, and then change our source code editor. So since I'm on Mac, obviously I have Xcode. There's another IDE called CLine, which apparently a lot of people use. I think it's paid. Visual Studio Code is free, so I definitely prefer that. But you can change the IDE and then you can go ahead and click the Restart Now button if you change it, so that it can get everything set up with the new IDE, and it'll usually open up the IDE for you so you can get right to editing code files. Now, if you switch the IDE with an already created project, like let's say it was on Xcode, and then I switched it over to VS Code just now, then I would want to go to Tools and click this button here, which will say either Refresh Visual Studio Code Project or Generate Visual Studio Code Project. And doing that will just make sure that all of the files are set up correctly for Visual Studio Code to read it. And of course, you can go to Tools, Open Visual Studio Code, and it'll go ahead and open all of the relevant files here on the left side. So you can see there's sort of two categories here. The top category here is the actual project, which we're working on, which is the tutorial project. And then the bottom one is the source code of the engine. So currently, typically when you install Unreal, you actually get the full source code of the engine. So if you want to change stuff around in there, you can do that as well. But most of the changes we'll be doing will be in our specific project, and we can go to Source, Tutorial Project, and then we can see all of our different classes and files here. So with the Arduino IDE, typically what we would do is we would have just one file, which would be called whatever the program name was, .ino. And that's kind of similar to one of these .cpp files. So these are where you have the actions of the program and what gets done. Then we kind of split it into two files. So the .h file for each sort of program contains like the data. So you can see here, it contains the description of the object and like all of the properties. Each of these is a different property that you can change about the object. And then in the CPP file, we have the functions which we can use. These are things like the setup function and the loop function to actually modify the state of the object or change how it interacts with the world. So what we're going to be doing is we're going to be modifying our character in this tutorial. So the first thing we're going to do is we're going to open up it'll be called whatever your project name is, character.h, and project character.cpp. So if the project was called my first project, it would be my first project character. And the class here would say class A, whatever the project name is, and then character. So it just default names your character for you based on your project name. Now, a little convention here is that Unreal uses is all of the classes for objects, or actors more specifically, which is a subclass of object, start with the letter A. So you can see if we open up a hierarchy here, it'll be a little bit easier to understand how this sort of class system works. Basically, at the very top, we have the idea of an object, and an object is just some digital thing which we can do code with. So this could be anything from one of these cubes to this rifle here to the main character, which we're going to be when we walk around. And we sort of subdivide that into things with more and more detail, each of which are called classes. So if we were to go to Tools, New C++ class, you can see that we could make it a subclass of any of these classes that we already have. So at the top, there's the object class, which is all of the objects at a very, very basic level. And then we have a subclass of that, which is the actor class. Now, this is for anything that will actually like move and interact with the world. So these cubes or this rifle would be actors. These blocks here would be actors. The main character is an actor. So a lot of the stuff that we're going to be working with is an actor, because an actor is something that has a position and rotation and all of that, and is actually in the world. If we were to create a class for like a file that stored information about the player, that wouldn't be an actor, because it's not something that does something and exists in the 3D space of the digital world. So under actor, even more specifically, we have obviously all these types, but the one that we're going to be working with today is we have a character. So if we search for that, you can see that under actor, we actually have the subcategory of pawn, which is anything that the player can move around. So this could be like a vehicle or a person. And then we have character, which is more specifically a person. And obviously, you can modify, you could theoretically make a vehicle that was out of the character class, but it contains a lot of methods that are very useful for character related features. So if you were going to make a vehicle, you would probably want to have it derive from the pawn class. So inside of our character, you can see we have our specific character types. This is the general character type, which would be across all Unreal Engine projects. And then inside of that, we have this specific project's character, which if we modify that, then it won't change the base character, which it would be used across lots of projects. It will only change the character for this specific project. So obviously that's what we want to do. And we've already opened up the files for that here. It's the tutorial project character.h and the tutorial project character.cpp. So we can go ahead and play the level to see what functionality is already built into the character, and then add functionality from there. So you can see we can already walk around using WASD. We can jump using the spacebar. And if we pick up the rifle, which is over here, you can see we can also fire these little yellow balls which bounce around. So that's all of the functionality that is built into the character right now. Functionality for moving using WASD and the spacebar for jumping, and then also functionality for interacting with the gun. And obviously physics functionality for interacting with the world. You can even see we have these kind of arms which are holding the gun, or when we don't have the gun, which are just kind of hanging there. So basically we have these code files, right? The .h and the .cpp, and they define what our character will be like, what attributes it will have. And then we create what's called a blueprint that actually contains the information about how we fill out those attributes. So for example, in the code file, .h code file, you can see we're adding a mesh component, and a mesh is just a 3D model. And then inside of the blueprint, we say, okay, I'd like that mesh to be the player character arms. And then we also add animations and stuff to them so they don't just hang there like that the whole time. And we also add in a camera. But in the blueprint, we can position that camera how we'd like. So if we want this person to be a little taller, I could just drag it up a little bit. Then if we compile and save that and then play, now we're a little bit taller. And yeah, so the basic idea is you create the functionality and the core for how it'll work in code, and then you actually define what mesh there's going to be, where the components are going to be positioned in the blueprint, which is itself a subclass of the class we're creating. But we can edit it with a fancy GUI, so we could also, if we were in a professional environment, do our programming and then hand off this blueprint to an artist or someone who doesn't know how to code, and they could use this fancy GUI to edit all of the variables. So what functionality can we actually add to our character and then edit in the blueprint? So we already have movement. Let's add something of a sprint system. So if we can already move around using WASD, but we can make it so that when we hold down the shift key, we go just a little bit faster. So the first thing we need to do is we need to define a new input. So by default, we already have, if we go into first person input actions, we already have the input action jump, the input action look, input action move, and input action shoot. So you can see we already have all of these input actions, but we want to add another one for sprint. So we can right click on one of these and duplicate it, and then rename it to, the convention is IA for input action underscore sprint, since this is going to be our sprint. And then we can edit it. So the triggers here, we copied the shooting functionality, so it's going to already have probably the mouse button as the trigger for the action, but we want to change that to be something like the shift key. So if we open up the IMC underscore default, there's basically these input actions, and then we connect them all together with one of these input mapping control pieces. So the IMC underscore default already has jump, move, and look, and then we just want to add a connection to our new input action sprint. So we just plus add a new item to this array and then select the input action sprint. And then we can change the input that triggers this action. So as you can see, we already have, for example, the jump action, and you can see it's triggered by either the space bar or the gamepad face button bottom, which is like the A button. So on our sprint, we could go ahead and add two different things, and the top one could be the left shift for when we're on keyboard, and the bottom one could be when we're on controller. We would want it to be when we click the left stick down. So we could say left stick button. Gamepad left thumbstick button. So now if we were on controller or on keyboard, we can trigger the sprint function in the way we typically do. And it's connected in our IMC default. So now we just need to add some functionality to our character script that will allow it to check if that input action is being triggered, and if so, start sprinting, speed up a little bit. So you can see if we go into our code, you can see we have the same sort of setup here. We have the jump input action here and the move input action here. So I'd like to just copy one of these, go down a little bit lower, and paste it. And now this is going to be our sprint input action, because we want all of the same settings as these so that it can appear in the exact same way. And then we'll just rename it to sprint action. And this is in the header file, so all this stuff here is about setting variables. So you can see if we were to search for one of these, it would show up in our blueprint. We already have the jump action. We need to be selected on the main class here. And then you can see, oh, we already have a jump action and it's assigned to that input action for jump. So what we want to do is we want to compile this now that we've added our sprint action. And if it successfully compiles, we can go back to our first person character. And once it's done, we'll be able to assign our sprint action. So you can see we already have the jump action, the move action, and the look action assigned. And once it compiles, it shows us that now we have a sprint action as well. And we can assign the sprint action that we created to fill in that category. Okay, so now we have a sprint action, which is triggered by pressing Shift, and we're able to access it in our code. But our code currently doesn't actually do anything with that sprint action. So we want to go into the CPP file and see what are they actually doing with those input components once they have them in the script. And you can see what they're doing is, with each of them, with the jump action, the move action, the look action, they're running this function, enhanced input component, bind action. So functions are triggered with either a dot or an arrow, depending on whether you actually have the object or have a pointer to it, which we'll talk about more later. But for now, we can see, we can basically just, again, copy what they're doing here because we're looking at doing a very similar thing. Now, what we probably want to do is we probably want to start with the jumping functionality, since jump has a press down and a lift up that are both used by the program. And so we want to start with that and then modify it as needed to make it a sprint and obviously not a jump. So first we change it so instead of triggering the sprint action, or instead of triggering the jump action, it triggers the sprint action. And then we want to change what functions it calls. So here at the very end, so first it takes in an action and it says when that action happens, it'll give some kind of event. So there will be an event when it started, an event when it's complete, and a whole bunch of other events like while it's being pressed, and so on. And then we want to say, okay, what object are you going to call a function on? In this case, it's this object. And what function are you going to call? Now, instead of calling jump and stop jumping, we want to call our own functions, which maybe we'll call sprint and stop sprinting. And then, of course, we actually need to add those functions. So back in the header file, we declare functions. And once again, we're going to be imitating the style that they have done for the other input actions. So we're going to create a, so we can go ahead and add a comment here called for jumping / stopping jumping. And then we can create two functions. And this is basically the same as when we're creating functions for Arduino. We'll say the type, which in this case is a void because we don't want to return anything. And we'll have void sprint. And we're going to, yeah, and that's it. And then we're going to want to have a void stop sprinting. Now in this file, in this header file, all we do is declare what the functions are going to look like. We put the signature here, so you can see all of these signatures, and then in the CPP file we put the implementation for what it's actually going to look like. So if we click on the text here, the name of it, then it will typically give us an autocomplete option to go ahead and add it over to the other file. But if it doesn't, this is a good opportunity to learn how to do it ourselves. So the way it's structured in here is we say the type, and then we say the actual class. So we do have to repeat this A tutorial project character class for each function, because we're saying on this object we want to have the function sprint. And then we can actually put our code inside of this function. And then we obviously need another one, A tutorial project character : stop sprinting. And these two functions are already set up here to be linked to this sprint action. When it's started, it'll run the sprint function, and when it's completed, it'll run the stop sprinting function. So the next thing we need to do is, now that we know when we're started sprinting and when we stopped sprinting, we need to actually get a handle on the speed so that we can modify that when we're sprinting and when we're not sprinting. So we can increase the speed in the sprint function and then decrease it in the stop sprinting function. So let's go ahead back to our blueprint and take a look at where the speed is controlled. And we can see we have this character movement component. And if we search for speed, you can see we have this max walk speed variable, and this is the variable that controls our speed. If we were to double this from 600 to 1200 and then go ahead and play, you can see we are much faster. The acceleration is still the same, but we can accelerate up to 1200 instead of 600. So that's what we're going to do, is we're going to set this max walk speed to 1200 while we're sprinting and to 600 while we're not sprinting. So if we go into the sprint function, we need to get a hold of this character movement component. And fortunately, there's a handy function for that called get character movement component, which will give us this component since we're already on a character. And this is where the power of the class system comes in. Because if we were to go back up to the character, which remember our specific character is a subclass of the general character type, we would see that they've implemented this function because all characters have a character movement, so all characters can run this get character movement component function to get that character movement component. So yeah, we can basically use these functions that were created higher up in the hierarchy for our more specific use cases. So what we want to do is we want to get the character movement component, and then we want to change the max walk speed to 1200 since we're starting to sprint. And we do seem to be getting a couple of errors here. So let's go ahead and see what those might be about. You can see if we go ahead and compile it in Unreal, then it'll give us a more detailed description of the errors. Sometimes VS Code can be incorrect when it might think there's an error when there's not an error. So you always want to compile with Unreal to check if there's actually an error. And in this case, there is. So you can see what it says here is, for example, for the top error here, we have no member named Sprint in a character. So it's saying that it can't find the sprint function that we're asking it to find. And the reason for that is we typed in a character, as if we were trying to call a sprint function on the character, which is the superclass over top of this class. But we are working with the A tutorial project character. So we need to call the sprint function on the tutorial project character and not on the larger character class. So if we fix that, now we're calling our sprint function and not asking for a sprint function on the character class. So those errors are now gone, and we have the get character movement component is still giving us an error. And it's saying that we don't have that function. Now, I think it might actually not be a function. We might actually not have to run a function. We might just be able to get the character movement component as a variable. Not entirely sure, but we can go ahead and try that. If that's a variable of the character class, then we could just go ahead and access that and use it. And once again, we're getting an error. So let's go ahead and see what would happen if we don't know how to get the character movement component. We know it's here in our blueprint, but we don't know how to access it. So we can just go ahead and look up Unreal CPP for C++. You always want to add that because otherwise you might get instructions for the blueprint method of programming, which will be obviously much different. So Unreal CPP get character movement component. And as you can see, there's a few different results here, so we'll just skim through them and hopefully find one that's useful. So here you can see we have character movement. So they're saying that the character just has a variable called character movement. Now here, we are a subclass of character, which means that we are a character. So if that's true, then we can just say character movement, and we can get the character movement component like that. It's still showing an error, so obviously that may not be correct. But let's go ahead and compile and see what error message it gives us this time. Okay, and now it's saying that's a private member. So that means that the character class does have this character movement variable, but we're not allowed to access it because we're in a subclass and not the main class. So this is correct, but we can't actually do that. That would work if we were in the character class, but since we're in a subclass, it won't. Now, a little further down, they're saying there's a function called get movement component, which is, I believe, what I was thinking of. It's not get character movement component, just get movement component. And that will probably return to us the character movement component that we are looking for. And once again, we are getting an error, so let's see. Okay, so now it's telling us that we're accessing what it calls an incomplete type. And what this means is that we're accessing something that's valid, but it doesn't understand the way to interact with that object or the information about that object. And the reason for that would be in this include section, we haven't included the information about our character movement component. So it knows that that's a thing, that's perhaps a variable of the character class, but it doesn't know what the variables of that object actually are. So in order to do that, what we have to do is we have to include a file that'll tell it what the variables are, which is the .h file for that component. So for example, if in another script we wanted that script to know how our character works, we would include this file, tutorial project character.h, and then it would know how our character works and how to work with our character. So what we can do is we can search for Unreal CPP include character movement component. And here we have the U character movement component. And you can see it gives us #include for that, which any of the documentation pages for any component or actor will give you this #include so that you can include it. And it is at gameframework/character movement component.h. So now we're including that file. It'll know how to actually deal with a character movement component and what the methods and variables on that are. And now that it does, now that we have that, it's saying that there's no member named max walk speed. So now that we already have our character movement component documentation up here, we want to search for how to set the max walk speed. So if we search for max walk, then you can see it has a float called max walk speed, which I believe is what we have here. max walk speed. Yeah, so we don't appear to be getting, yeah, so obviously something is mistaken here, because what we're seeing in the documentation is that it does have a float max walk speed, but we don't seem to be able to access that. So let's go ahead back to where we were looking for getting the character movement component and make sure that side of the equation is working correctly. Okay, so there seems to be a divide between get movement component and get character movement. And you can see if we change it to get character movement, this error disappears, so it looks like we're actually going to be able to do that. So, yeah, forget you won't remember all of the function names for all of the different components that you need to get for a character or for any other class. So you will have to go through some amount of Googling, but typically when you see the right one, you will, after using it several times, you'll know, oh, yeah, that's the right one. How could I forget that? And then you'll forget it again the next time, and you'll have to Google for it and go through the same process. But that's what programming is. So we go to sprint, we set it to 1200, and for when we stop sprinting, we set it back to 600. And then we just want to compile that again because we made a change, and then we can run the program and see what happens. So far, we've created a sprint action, and we've told our script where that sprint action is, and then we've told it when that sprint action gets triggered, like when I press shift, we want you to speed up the movement component, and when you let go, we want you to slow it down. Now, obviously it's not doing anything. As I hold down the shift key and release the shift key, we're not seeing any modification in speed. So if we press function F8, it doesn't stop the simulation, but we can break out of the player character for a second. And if we go over to this outliner here, if we go through all of the folders, we can find our player character. So our player character is this BP underscore first person character. And what we want to do is we want to look for the max walk speed. And we can see it's 600. Now if we function F8 again to get back in, oh, well, it disappeared it. Typically, you can click on something. There's also shift function F1 to just release the mouse without separating from the character. And you can see, all right, so now we have those variables there. And you can see when we press shift, it just changes it for a split second. You can see it just flickers there because it's changing it to 1200, and then it's immediately changing it back. So let's go into the we know, okay, so let's take a look at what might be going wrong here. So we have a few areas where we can look to see what might be going wrong. Obviously, there's the script where we're connecting to the action, and then there's the action itself. Because if you remember, when we copied this, I believe we copied it from the shoot option. Or from the shoot input action, sorry. And the shoot input action obviously behaves differently than a sprint. We want sprint to behave where you hold it and the sprint continues. So if we check at the jump here is, I believe, the same thing where when you hold spacebar, it continues for a certain amount of time. Obviously, it has a max. And you can see the jump just doesn't have any triggers here. So if we go to triggers and we just trash can this, let's see what happens, because that's what they're doing for the jump. Perhaps it'll work for us with the sprint. And you can see when we hold it down, it's now speeding up, and when we let go, it's stopping. So one of the most powerful things you can do when you're adding functionality is you can look and you can see what is the most similar functionality that's already built in, and how can I imitate or emulate that? How can I make it similar to that in the way it works, while obviously having a different function? So we basically just copied exactly what the jump is doing, and we've just said, hey, instead of making player go up, make player go faster. That's it. And when we dumb it down to a small change like that, where we're keeping everything from the jump except for that one thing, and just changing that one thing, it makes the problem so much easier to solve. Okay, so we've got sprinting, We can increase speed and decrease speed, but by holding the shift, increase speed while we hold the shift, and then decrease while we let go. Let's add a crouch next. So what should crouching do? Crouching should do a few different things. If we look at our character, obviously crouching should decrease speed, but crouching should also, it should make the player camera go down lower so that they feel lower, and it should make this capsule, which is their collision, shorter. Because obviously if they go down lower and they think they're this tall, where my mouse is right now, they don't want to still be banging into some block that's right here. So we need to shrink this capsule down so that they can go under a block if it's like right here. So yeah, so this is going to be a few different components. Move player camera down, shorten capsule, and unlike the sprint, we don't want to immediately snap between the two options, because if we were to just snap this shorter, snap camera down, it would be a snap transition. It would probably be like, it would be a jolt. The player wouldn't like that. So we need to gradually, smoothly lower the height of the capsule and smoothly lower the height of the camera, and do both of those at the same time, so that as the player gets shorter, they also feel shorter. If they're walking into an object, then they would pass through it the same time as their camera gets low enough for them to feel like they should pass through. Right, so yeah, so that's, but before we do that, so now we have 3 different speeds going on. We have the regular walk speed, we have the sprint speed, and we're going to have the crouch speed. So setting all of these in code is going to be kind of a mess. We want to instead use variables, just like we did back when we were programming Arduinos. So I'm thinking we change the sprint speed down to 900 because 1200 is a little fast, and we make the crouch speed 300. But obviously we want variables for all of these, which make it clear what our code is doing, because right now, stop sprinting, if we ignore this function, setting the max walk speed to 600, what does that mean? Why are we setting the max walk speed to 600? They don't know. But if we say we're setting the max walk speed to walk speed, then it becomes pretty clear. Oh, we're stopping sprinting by setting the speed back to walk speed. And in here, for sprint, we can say we're just setting the max walk speed to sprint speed. And now it makes it super clear what's going on here. So obviously we need to declare these variables, and we're going to do kind of a similar thing as we did with the input action. We're going to want to keep this U property tag here that we have intact, because the edit anywhere means that we are allowed to edit this variable in different situations, and the blueprint read only means that it doesn't make it read only. You can still read and write it. But it means that in the blueprint, we're actually able to access it as well. So we want to keep both of those. Category is just for sorting. If we search for input, this is what a category looks like. The input category has all of these different components, which you can see here is set by saying category equal input. And we can make new categories. So we can say category equals movement, perhaps, for our sprint speed, because that makes sense. And then the other thing is, that's nice, is if we hover over the jump action, the text, it says jump input action, which is this comment right here above the jump input action. So the comment on the line directly above this, which you can create using the // or by using the /*. The comment directly above the line is also used as the tooltip, so that when you hover over it, you get to see that comment, which makes it super easy for a programmer to explain to a designer what's actually going on with a certain variable and how they should use it. So we don't want this to be an input action. We want this to be an integer, just like in the Arduino IDE. We have integers, same thing. Okay, actually we probably want it to be a float. Also, just like in the Arduino IDE, we want it to be a float. Float, sprint speed. It could be an integer. It's just, I don't know that I've ever set it to 1,500, but if you wanted to, you could. Float, sprint speed, and then we can set the default value of the sprint speed, so it's not just 0, because obviously then by default our character wouldn't go anywhere. This kind of gives a designer maybe an idea for, oh, this is a general value, and the designer can use this arrow here to reset back to the original value. So if they're like, what kind of a value should this be? Should it be in the millions? Should it be in the tens? They can reset it back, and they can be like, oh, the original is 900, they can test it out and be like, oh, maybe a little faster, let's make it 1,000. That kind of a thing. So it just gives an idea of what a general speed might be. Okay, so then we're going to have the walk speed and the crouch speed. And obviously we need to rename these variables to walk speed, which is going to be 600, and crouch speed, which is going to be 300. We have 900, 600, 300, and they're all under the movement category. So if we go back and we compile this, we'll be able to search for movement, and once it finishes compiling, we'll get a new category called movement, which obviously doesn't exist right now, and it'll have those 3 variables inside of it with their default values. And here it is, right here. Sprint speed, walk speed, and crouch speed, and we can obviously tune those as we want to. So now that we have those speeds and we're using them here, sprint speed and walk speed, we need to add the crouch function to actually use that crouch speed. So let's do a similar thing to what we did last time with the sprint. We can use Control D to duplicate it, and we can call it IA underscore crouch. And the convention, the general naming convention in Unreal for files is you call them the abbreviation for what they are. So this is an input action. So we say IA and then underscore and then their name. So IA crouch. Another example of this. This is an input mapping context. IMC underscore default. And our BP underscore first person character is a blueprint. So we call it BP underscore and then the name. So all of these, yeah, that's the general convention for naming in Unreal. So now we have crouch. We're going to leave it with the same settings for now, though we may need to change them in a moment once we see how it actually works. And then if we select our default input mapping context, then we can select from the drop down, we can select the crouch option. And then we just want to add a couple of inputs. Now, basically the idea here is, so you have the sprint action and the crouch action and the jump action, those are all global. But you could have different input mapping contexts. So we could have a default one, we could have a left-handed one, and then you could switch between them to give the player some options for how they control, for how they actually trigger the crouch function or the jump function and so on. So this is all about customizability. So right now we're just using one input mapping context, and that's the default one. But we could create others and have variations on what control scheme people are using. Okay, so the crouch action should be triggered by the left control, or on gamepad, it should be triggered by the right face button, which is what B would be. Right face button. Gamepad face button, right. Okay, so now we have the triggering of the crouch, and then we need to add it in our program the same way we added the other input actions. So we'll copy the sprint input action, go down a little bit lower, change the comment to crouch input action, and change the title of it to crouch action. And then we might want to just go ahead and compile and set that before we forget. We're going to be searching for input again, and it'll appear here once it finishes compiling. And yes, a word of warning, it does take much longer to compile than the Arduino IDE did, because it's compiling a whole bunch of programs. You may be wondering why we have all of these. It also crashes sometimes, which is what happens here, so I'll just explain this while I restart it. We have these include lines at the top of our file. Why don't we just include all of the files? Well, the reason is when we make a change in this file, this CPP file, it goes through and it has to read all of these files and all of their include files and all of their include files all the way back up the chain to compile this file, because we might be using any of those, and in fact we're using all of those files that we hash included. So if we were to include all of the files, it would take an astronomically long time to compile. So instead, by default, it doesn't consider any files. It only considers the ones that you explicitly include to keep the compile time down. So since it crashed, we need to compile it again. And then we can, actually, I don't think we needed to compile it again. When it starts up, it compiles, and if it can't compile, then it'll let you know that, and you can fix stuff before it'll actually start running again. Okay, so we don't need to be playing. We need to check the first person character for the movement category, for the input category, and we need to set our crouch action to input action crouch. Okay, and now that we have that set up, we can once again implement our crouching function. And we forgot to rename sprinting the comment over jumping to sprinting. So let's just copy this, paste it in, and rename it to crouching. And of course we want to bind the crouch action to both of these, and we want to run crouch and stop crouching. Pretty simple, but it's going to get a bit more complex. But for now, let's just go ahead and continue copying these. What really gets us is not the fact that we have to edit a couple more things. The capsule component and stuff, we have to edit those. Those are just going to add like one more line basically. But the smooth transitions, that's where it gets hard, because at a smooth transition, we need to run it based on time. So I'll explain what I mean in a second. I think, okay, so for the sprint, we did a hold to do it. So for the crouch, let's go ahead and do a toggle, just so you can see the differences between those. So instead of having a completed event, we're just going to have the started event, and we're going to run a function called toggle crouch. And you could do the same thing we're doing. Between the sprint and crouch, you'll see how a toggle system works, and how a hold system works. So a fun activity to try might be change sprint to toggle and change crouch to hold, and see if you can do that. So we're going to create a function called toggle crouch, and of course we need to create a definition for it in our main file. So void toggle crouch. And since we're toggling, we need to have a boolean that'll tell us whether we are already crouched or not. So up at the top, I'm going to create a bool called b is crouched, and the b is just another. I know we're going over a lot of stuff in this video, but another convention in Unreal is they usually put b before their booleans. So it's b is crouched, and that's going to start out as false. And basically in the toggle crouch function, we can say if b is crouched. See, this is looking more like the Arduino stuff, right? If we're already crouched, then we want to uncrouch, and if we're uncrouched, then we want to crouch. And I'm going to create another function for starting and stopping crouches. And this is it would be unnecessary, except that there is one other place where we're going to call the stop crouch function. So we need to have a separate stop crouch function, or we'd have to copy and paste code, and that's having the same exact code in two different places is just a recipe for disaster. You should always create a function, because then any changes that you make will be preserved in both places, so you don't get confused. So we're going to create a void start crouch and a void stop crouch. Pretty straightforward. And then we'll just create them right below here. A tutorial project character, : start crouch. And then we can Command X this, or Control X, and paste it in there. And then we could copy this whole function and have a stop crouch function, which will instead change the crouch speed to the walk speed. Okay, so that's pretty straightforward. If we're already crouched, then we want to stop crouch, right? Because we're already crouched, so we want to switch to not crouched. And if we're not already crouched, then we want to start crouching, because this is when the player presses the crouch key. So we'll start if we're not started, and we'll stop if we are. And then we also want to set that boolean, obviously. So b is, was it is crouched or is crouching? B is crouched. B is crouched is going to be true when we start the crouch. And B is crouched is going to be false when we stop the crouch. So now that boolean will also always be correct. And if we implement this, we should see that the crouch speed should now work for us. We have a second Visual Studio Code window open. I think that's the one it auto opened. Another shortcut, you can press Command or Control and Shift and S. So Command Shift S or Control Shift S all at once. And instead of being a save as, it's actually a save all. So if you edited 5 files and you do Command Shift S, it'll save all the files. Pretty handy. Okay, so now if we press Control, it doesn't do anything. All right, this time I did actually think it was going to work. Crouch action started, toggle crouch. And we have already linked up the actual crouch action. And it is, so remember how we modified the sprint action so it would be like the jump because we were doing a hold action. We don't want the crouch to be like the jump because we're not doing a hold action. So if we go to shoot, which is something that starts and stops, you can see it has triggers pressed added. So what we want to do is just do the same thing there. So it would have been a better idea to copy shoot for crouch since we're doing a toggle action, which is more similar to a triggering action where you press a button and it shoots out a bullet. So you can see under triggers, if we plus add, you can see there's a few different options. So like there's combo actions and all kinds of stuff. But what we saw under shooting was the pressed option. So if we select the pressed option and we play again, now moving along, press Control, still doesn't work. But at least we got that out of the way. At least now we have that just in case there are problems with that down the line. So we're running the toggle crouch function. And when we get into it, if we're crouched, which isn't true at the beginning, so the first time we press it, B is crouched is going to be false. So we're going to be running the start crouch function. Good. We set B as crouched to true, and we set the max walk speed to crouch speed. That all seems good. So let's try our trick of playing and then going over to this side window here, clicking on BP first person player and searching for speed. So we can, I selected the wrong thing. The BP first person character is what we actually want. And we're looking for, there we go. No, not that. We're looking for the max walk speed, and we're going to see how it changes when we press Control. So walking along normally, press Control, max walk speed does not change, not even remotely. Okay, so obviously something is up here. And we've stepped through the logic, and it makes sense. And we're looking at our thing here, and I just want to check if sprinting works, because obviously sprinting is another mechanic we've added. So if sprinting doesn't work, then we'll know, oh, well, maybe something's wrong with the whole program. So let's watch our movement walk speed. Shift to sprint still works, but obviously tapping Control does nothing. So let's go ahead and examine get character movement, max walk speed equals crouch speed. Start crouch, we should be running start crouch. Okay, so I mean, I've done everything I know to step through the logic. So the next thing is to start printing things out to the console. That's the easiest way to find out where an error is. So you can see, oh, is step 1 happening? Oh, is step 2 happening? Oh, is step 3 happening? Let's see what's happening. And the way we print errors out to the console is way more annoying than serial monitor.println, unfortunately. So first, let's see if the toggle crouch function actually runs. So we do the function uelog, all caps with an underscore in between, and then log temp is the first parameter, warning, text, and then inside of there we put our message. In this case, we're saying toggle crouch ran. Okay, so what does this actually do? The uelog function is the function to send a debug message to a log. Then there's what log we're sending it to, and so you'll basically always use log temp for this because that's the main log that we're going to be checking. And then you can say either a warning, or which makes it show up as yellow, or error, which makes it show up as red. It doesn't have any functionality other than that. It's not going to change the code around it if you say error, it's just going to make it red. So it's just color coding. So I usually use warning because it stands out, because most of this stuff is just standard white text, if you take a look at this. And more important things, we can just set them to warning so that they just stand out a little more. Obviously, we're not going to keep this in the finished build, so it doesn't really matter. We could also set it to red, which would stand out a lot. But I just like to set it to yellow by default. Then the next thing is we have a text thing here in quotes, and then we also add the text macro around it. So it should run if you do it without that. But what that does is it makes it basically cross-platform safe. If you don't add the text macro, then sometimes just saying this text will mess up on certain devices. So it's just a good habit to get into, to always put that text macro around your text when you're calling this function. To say, hey, this is going to be text. Alright, so let's go ahead and compile that, and now we will be able to tell by looking at the log whether or not the crouch function, the toggle crouch function, is actually running. And if it is, then we can step a little further down the line, and if it isn't, then we can figure out why it's not running. So I'm going to walk around, I'm going to tap crouch. Okay guys, it's working now, and I think I know the error. It's a very, very important error. Forgetting to compile. I think that whole time, while I was debugging, I forgot to compile literally the entire time until I added this one line of code, and then I remembered to compile, and now it works. So if you don't compile and add your changes, the changes will not be there. Very important step. So now that we have, we're able to toggle movement, we can go ahead and move on to sort of the shrinking of the capsule and the movement of the thing. Someone in the chat said they also like C++. I like C++ a lot, except when it crashes on Unreal Engine, because it doesn't really have safeguards, which is something that you'll find out. Which it also didn't really have safeguards on the Arduino either, but the Arduino had some safeguards. So Unreal Engine doesn't have a whole lot of safeguards. There are plenty of errors that it's going to miss, and it'll crash the engine. So yeah, that's a slightly annoying thing that you do have to get through. Okay, so let's go ahead and modify the height of this capsule component so that the player is shorter and doesn't collide with things and can go under things while they're crouched, and the height of this camera component so that they visibly see their camera go down when they press that crouch button to toggle crouch. Alright, so smooth movement. How can we achieve smooth movement? And we're going to be doing this entirely through the scripting. So we're not going to be creating an animation or anything like that. It's kind of like an animation, but we're doing it in the script. So the way we achieve smooth movement is by using time. We need to keep track of time, and let's say we ran a function every second, we moved it down a certain amount. Now, unfortunately, nothing in a computer game can run that precisely every second, because sometimes frames take short time to render, sometimes frames take long time to render. Depends on the hardware, depends on moment to moment what calculations have to be made. So what Unreal has done is they've put in a function that runs every frame. It's called the tick function, and what it holds a variable that tells us how much time has elapsed between frames. So we can say inside of the tick function, every frame, we can say, based on how much time passed between the last frame and this frame, let's move the capsule down a certain amount. And that will make it smooth, because if it's been 1 second, that would be a terrible frame rate, 1 frame per second. If it's been 1 second, we'll move it all the way down. If it's been half a second, 2 FPS, then we'll move it halfway down. If it's been 0.01 seconds, we'll move it 1/100th of the way down. So we get smooth movement based on time, and it's the same for every player, regardless of their frame rate. It'll still take the same amount of time for it to drop. It'll just be smoother if they have a faster frame rate. And that's how basically everything in games works, from movement to shooting to anything else. They harness the time between the last frame and the current frame to figure out how much a certain thing should move. Someone in chat said you should make games. Well, I I mean, that's what we're doing right now. Hopefully down the line, after a few tutorials on basics, we can actually get into making a game, me plus chat, making a game and shipping it and seeing what happens. But that's a little further down the road. Right now, we're just doing some more basic tutorials to get a handle on how this works. So what we're going to do is we're going to harness the power of that tick function to actually be able to run every frame and read the amount of time. So let's search for Unreal implement. Actually, we could also search through the code files here and find another code file that implements this tick function and then borrow from that, because that's it's a really important programming concept. A lot of people don't like it when you say that, but that's basically what programmers do all day, every day. They borrow some functionality, they modify it to be a little bit different for their use case, and then then they have a program that works and that does what they want it to do. So we can borrow from one of these, or we can search it up. You have to just use your best judgment on which is fastest. So let's search Unreal implement tick function. And the reason we can use a tick function is because we are a subclass. Our character is a subclass of character, which is a subclass of a actor, or just actor. They all have the prefix a before them. So actor has the tick function built in, which means that any character can use it, and any specific instance of our character can use it, and any subclasses of our character could also use it. You can go all the way up to your parent. If we weren't a child of character, which is a child of actor, then we wouldn't have that tick function. So let's look for some. Okay, so I forgot to add CPP for C++ to it, and it's important that you add that, because otherwise you'll, as I said, mostly get blueprint results, which is obviously not what we want. Okay, and here we go. Here's the implementation. Super quick and easy. Void, whatever the thing is. This is always whatever the name of the class is, and then tick. And then I think it goes actor, then pawn is a subclass of actor, then then character is a subclass of pawn, and then our character is a subclass of character. So I think I missed pawn when I was mentioning that before. So yeah, actor, then a pawn is an actor, then a character is a pawn, which is an actor, and then our character is a character, which is a pawn, which is an actor. So we have this, we can implement this. If we go into the CPP, we can add where should we add this? Let's add, hello. Let's add void a tutorial project character, : tick. So remember, it's always going to be this, the name of the class, : and then the name of the function. And then we also had that float delta time, which, as I said, is the time between the last frame and this frame. So if it's been 1 second, because we're moving at 1 frame per second, then what we're going to do is we're going to move the capsule all the way down. Say it's a 1 second transition time. But if it's only been 100th of a second, we'll only move it 100th of the way between where it is and where we'd like it to be. And yes, the actor is based on the object class. So yeah, once again, I think there's another way to view the hierarchy. Class viewer, yeah. Tools, class viewer. You can kind of, well, I guess this doesn't go all the way up. So if you go to tools, new C++ class, then all classes, you can really view the hierarchy. Object, and then actor is an object, and then there's all these other, well, first of all, there's all these other objects, right? And then there's actor, which is just one of the many, and then pawn is one of the many subcategories under actor, subclasses under actor, pawn, and then there's only 2 different pawn types. One of them is character, and then there's 4 different characters. One of them is our specific character, which we're adding functionality to. So basically, the next thing we have here is this super : tick delta time. What is this? Okay, so subclass means stepping down 1 class, right? So actor is a subclass of object, right? Superclass means going 1 step up. So object is the superclass of actor. So what super is doing is super is saying go one class up. So, and then call the tick function with this delta time variable. So if we were to go into character, which is the superclass of our character, it has its own implementation for tick, and there could be lots of important stuff in there, right? If we don't call that, all that important stuff just gets skipped because we're saying, hey, let's replace that with this new function. If we say super tick, then we're saying, hey, let's do that function and add all of our new functionality. That's not how you spell functionality. So basically, you anytime you're using a built-in function, your default should be run super : that function, because otherwise you could be skipping super important functionality. No pun intended, but it's a good pun. You can see we're doing the same thing here with this begin play function. This is also something from, I believe, the actor class. We're running super : begin play, which will go and run character begin play, which will go and run, because it also has super : begin play, it'll go ahead and run pawn begin play, which will go ahead and run actor begin play. So it'll run all the way up the chain so that none of the steps get skipped. And if we didn't run this line, if we didn't have this line, we would skip all of those steps, which would be a big problem. Now, there are reasons why, in some cases, not, I don't think ever in the case of tick or begin play, but in cases of other functions where you might not want to run the stuff from the super classes, in which case you don't use this line. But we definitely want to run all of the tick stuff that happens for the general character class. So yeah, we go ahead and run that, and then we'll add our custom functionality. But you can see it's giving us an error because we didn't declare this in the .h file. So remember, declare it here, implement it here. You have to do both. And since we're overriding a function, we have to do this slightly differently. I'm looking for begin play because it's a similar thing. We type virtual void tick, and then remember, obviously we have to do float delta time because that's our parameter. Override. And yeah, so basically we're saying this is an override, and the virtual, it would take a lot of explaining to get through this. So basically, if you're overriding a method like this, then this is how you do it. We'll hopefully get more in depth with that at some point. Someone chat said that it's so much easier than standard C++. Yeah, there's something to that. There's a lot of stuff already done for you, which is why you would use Unreal Engine, is because it makes it easier. You could absolutely make a game with C++, and for like a text game or something where it's just like in terminal and you're just sending text prompts back and forth with the computer, that wouldn't be that hard. It would probably be a better choice than creating that with Unreal Engine. But if you want to create something with fancy 3D graphics, then obviously you want to harness all of the work that the company that made Unreal has done to get to that point. So obviously thousands, if not millions, of man hours of development have gone into creating this, all of this functionality, and we can obviously, yeah, it makes it a lot easier. That's basically the whole point. So back to our crouch function. What I'd like to do is I'd like to say, yeah, you can also use OpenGL. That's cool too. I don't have much experience with that, but I have seen games made with it. It can be very impressive. What people can do with that. So we want to say, here's where our, let's just do it one at a time. So let's start with the camera. We want to say, here's where our camera is now, and here's where we'd like our camera to be. So first, let's figure that out. We increased the camera position earlier, so let's reset it back down to 60. And then let's say when we're crouching, maybe we want it to be 40. That seems reasonable. I have no idea how it uses Vulkan abstraction. I haven't looked into that at all, so unfortunately I can't really answer that very well. So let's say we want to decrease it to 40 when we're crouching. So obviously we want to leave the default at 60, save that. and then we would like to go from 60 down to 40 smoothly. So inside of our start crouch, we could say, if we created a desired camera height variable, we could set that to 40, and then we could just move towards that in the tick function. And the reason we're doing it in the tick function is because it happens every frame, and we can use this delta time variable to make sure that we're transitioning between based on time. So what I'm going to do is I'm going to make it a little bit easier, because maybe further down the road we want to lower to 30 instead of 40. I'm going to make it a transition between 0 and 1. So 0 will be not crouched, 1 will be fully crouched. Or actually, let's flip that around. Since the crouch variable is a little bit lower, let's have crouched be 0 and uncrouched be 1. So let's create a variable. Probably want this to be protected. Okay, so quick note here. There are three categories a variable could be under. There's public, which means any script can use it. This is also for functions. So any script can create this object because its constructor is public. Under this public section, any script can access this look action. Any script can access if it has a rifle or not. Any script can run either of these functions. Thank you. I appreciate that. Protected means subclasses, right? So if we created a subclass of our character, for example, this blueprint is a subclass of our character, it means subclasses can access it, but other classes can't. So public means any class, protected means only subclasses, private means no one. We don't actually have any variables declared as private here, but private would mean even the subclasses can't access it. So earlier on, we were doing some stuff with the movement component, and the character has the movement component as private. So even though we're a subclass, we can't access it, but we can access the get character movement, which is, I believe, public. So anyone can access the character movement using this function. And the reason you set that up is so that if a variable is public, then you could read it, but you could also write it. And we don't want just anyone to be able to write some of these variables. We would like them to be able to read them, so we could have a function that reads them, but we don't want them to write to them and change our variables. So for example, further down the road, we might move B is crouched into the protected or private class, private areas, so that other scripts couldn't change whether we're crouched or not without us actually running one of these functions. Right, that would probably be a good idea. In fact, let's go ahead and do that right now. Since we don't have a private section, we can just leave it here. Private, now bool B is crouched is private. Not sure why we're getting an error. Anyway, for now, we don't need to delve into that too much because we're supposed to be doing this transition thing. So I'd like to create a couple new variables. One is going to be a float for our current transition. Let's call it our current crouched amount. That sounds reasonable. And our current crouched amount, okay, let's call it current standing amount, sorry. I just like to make sure that the variable name is accurate because otherwise it makes the code super confusing. Yeah, there are a lot of cool games made with Unreal. I notice Outlast, obviously there's big games like Fortnite or Rocket League that are made by Epic Games, who makes Unreal Engine. But yeah, there's a lot of really cool games even made by indie developers in Unreal. So the current standing amount is how much, and we can say 1.0 just to make it super obvious that it's a float. We can even say 1.0f, which makes it explicit that it's a float, which you have to do in some cases. This is, I don't believe, one of them, but it just makes it super explicit that it's a float, and not another decimal type like a double, which is more precise. Anyway, the current standing amount is how much standing we are. So at the start, we're fully standing, which means our camera is fully up, our collision is fully up, full height. When we decrease this, it'll go ahead and decrease the height of the capsule and the height of the camera so that we shrink down and we're lower and we don't collide with things, so we can go under things and we can feel like we're shorter because the camera's lower down. So basically, the other thing we want to have is an int desired standing amount. And the reason this is an int is because it's going to be either 1 or 0. It doesn't need to be in between because we're not trying to get to a halfway in between ever. We're either trying to get to standing or trying to get to crouching. So this could also be a Boolean, because a Boolean just holds 0 or 1. So that honestly might be a better case. Let's do that. And just like in the Arduino IDE, 1 and 0 are interchangeable with true and false. So we can just set a Boolean to 1. That means we're setting it to true. We'd like to be standing up. We'd like to be at 1 height. So what we want to do is when we're starting the crouch, we just change our desired standing amount variable. We change it to 0 because what we're trying to do is we're trying to get to not standing anymore. And when we stop crouch, we change our desired standing amount to 1 because what we're trying to do is we're trying to get all the way back up to standing. And then in the tick function, what we're going to do is we're going to say if the current standing amount is less than the desired standing amount. So if we're supposed to be going up, supposed to be getting taller, then what we want to do is we want to increase current standing amount plus equals, let's just for the moment say delta time. So the time between frames. So there's always going to be a delta time in this calculation because this is supposed to be time based. So basically what we're doing is we're saying if we want to be standing a little bit taller, let's add however much time has passed between the last frame and this frame, let's add that much to move us up. So if 1 whole second has passed, let's move ourselves all the way up to the desired standing amount. If 1/100th of a second has passed, let's move ourselves up 1/100th of the way towards that. Now, we don't want this to be exactly less than because imagine we're super close and then we add delta time, we might go over, and then we check and we go under and we go over, and it's just flickering back and forth really annoyingly. So we want to say if current standing amount plus delta time is less than desired standing amount. So basically if let's like we're saying theoretically if we were to add this much to our if we were to add this much to our height, would we still be needing to grow a little bit taller? And if the answer is yes, then we go ahead and add that. And now it seems like that will leave us a little bit below, but we'll fix that in just a second. Let's say else if current standing amount is minus delta time is greater than desired standing amount, because obviously we need to be able to shorten ourselves too. So if adjusting downward would still leave us taller than our desired, let's adjust downward. Current standing amount minus equals delta time. And the last thing we'll do is we'll say else current standing amount equals desired standing amount. So what we're doing here is we're saying, all right, so we have this adjustment from, which is the amount of time it's been between the last frame and this frame. If we were to do that, would we still be less than would we still not be where we want to be? And for either case, we either increase it until we're almost there, right? Because this calculation isn't true, or we're almost there in this direction, and then we just go ahead and snap to there. So basically the snap amount, what we're checking here is, hey, are we close enough that we would go over? And if we are, then we just snap it, right? So this snap isn't visible because we're only adjusting by less than delta time, by less than the amount we usually adjust. So it won't be noticeable at all. Okay, so now that we have that value, it'll go between 0 and 1 based on whether we're crouching and whether we're supposed to be standing or not. So this current standing amount variable is going to be changing there. So the next thing we need to do is actually set the camera's position based on this variable. So let's figure out how we can set the camera position. it's called first person camera. So we can run a function called get first person camera component. You can see it auto-completed that, always a good sign. And then we want to run set relative location. So when you're setting something's location, a component, you can either set the global location, which would be where this camera is in the whole world, or you can set the relative location, which is where this camera is compared to this actor that it's a part of. So in this case, this is its relative position here. If we were to change it to its absolute location, that doesn't make any sense in this editor here because it's not actually in the map. So it's... Right, we are having a weird thing here. This should be 60 or something, I believe. I'm just going to undo until we get back to where we were. But basically, the relative location is where it is compared to the actual actor component. So we saw earlier that its y value is 60 compared to the actual actor component. So what we want to do is change it between 60 and 40 for its z value, sorry. So its height is between 60 and 40 based on this variable. So what we want to do is we want to create a desired location variable. So an f vector is just 3 floats together, one for x, one for y, and one for z. So f vector, let's call our f vector desired, well, not even desired position, because this is the current position. Current cam pos equals f vector. We'll create a new f vector, and we'll say, okay, let's set current cam pos to get first person camera component. Let's see, we want to say get relative location. Sorry. So that's where our camera is currently. And then we'd like to have our desired camera position be a new f vector. So for the x value, we just want to use the current x value, current campos.x, that's a capital X. For the y value, same thing, current campos.capital Y. For the z value, we want to say 40, because that's the minimum, plus 20 times current standing amount. So what we're doing here is, let's just run through a couple of case studies. If standing amount is 0, it's just going to be 40, right? And that's what we want, because we're crouched. If current standing amount is 1, it's going to be 40 plus 20 is 60. And that's what we want, because we'll be fully standing up. And if this was half, it would be 20 times half is 10, 50, halfway between. So we can see that this is going to give us the correct value between 40 and 60 of how tall we should be with the camera at this moment. So then we can set the relative location to the desired cam pos. And that's it. Now we're setting the camera's location to where we'd like it to be. Let's test it out. By the way, guys, we are almost done. We just need to add the capsule component and then make a couple final tweaks. So hopefully this is done in the next 15 minutes, maximum 30. So we can go ahead and wrap this up. Also, if you guys have any questions, be sure to send them. Thank you for all of the questions that you've sent so far. I appreciate it. It gives me something to do here instead of just, talking to a computer screen. But let's go ahead and, okay, so we're having an issue where we can't move at all. Speed is like 0 or something. Let's check that. Obviously we did something wrong. Again, you can use Shift F1 or Shift Function F1 if you're on Mac to just free your cursor from the screen if it's locked in. And we can we already searched for speed, so I'm not sure why post process comes up first. Max walk speed is set to 600. Let's F8 to break free of our human prison and look at what's going on here, because obviously, wow, he's like completely frozen. I wonder if something's wrong here. Well, obviously something has to be wrong, but what might we have done wrong? So if he's completely frozen, that suggests that maybe we broke something with the tick function, because obviously the tick function is what most things rely on to actually have the time go by. So we do have our super : tick running, right? So that's obviously, we're not missing that. Obviously that's a big thing. But yeah, is there something else we messed up with? I wonder. Yeah, so let's go ahead and hop back in the game and see. Yeah, so we really can't move at all. Can't jump at all. Shift doesn't change anything. Control doesn't change anything. Not even the position of the camera, which it's supposed to be changing. I think we broke the tick function somehow, so it's not moving at all. A quick way to check something like this is comment out tick in the header file. Comment out tick in the CPP file, which you can just do with /* and then * / at the end, so we don't comment out anything else important. Compile that, see what happens. And yeah, basically if this works, then we'll know, oh yeah, it's one of those two parts, either in the header file or the CPP file, is what's causing the issue, which is a very powerful thing to know. However, we are still unable to move, so we know that neither of those things are causing the issue. Interesting. Let's see. I think we messed up something here when I was trying to show you the difference between relative and world locations. Yeah, because that could be it. If we reset that, then any changes that we made that might have broken it will be reset. Still didn't work, but I did see the hands move by, which means that it's not. Okay, so I guess it's just when we break free, it freezes like that. So yeah, something is what could be wrong? We just have no movement capabilities. Let's check our inputs, since we maybe default mapping context being missing. I think it was already missing from the start, but it can't hurt to try. Yeah, that's not working. Perhaps we messed up something in that mapping context. If we messed up one of the other, for example, the move. No, it still has the whole WASD thing going on. Looks pretty good. Alright, so what could be wrong? What else could be wrong here? We have to think through the changes that we made and how, well, really any changes that we made, because obviously we're pretty much lost on what is going wrong. So any changes that we made are potentially the culprit. Adding two variables should be fine. Did we add anything in begin play? Doesn't look like it. We already removed the tick function, which we added. Yeah, not a whole lot has changed here. So, crouch action is unbound. That's interesting. Okay, that doesn't seem to have worked. But at least we noticed that the crouch action was unbound and went ahead and fixed that. So I'm wondering what happens if instead of using our modified blueprint character, just in case there's something wrong with that, we change to using our the actual script character. Still unable to move, nothing much happening there. Although, yeah, that probably doesn't really help at all. Okay, no movement. I'm just gonna restart the editor just in case it's that, because I'm pretty much lost at this point. But hey, that's one of the ways that we can learn, is by figuring out something that we have completely no idea about. So let's restart the editor just in case it's a bug or a glitch. It might be wishful thinking. interesting. I hadn't noticed before, but obviously the look input is still working. It's just the WASD, spacebar, and crouch that aren't working. Shift just crashed the editor completely. It says caught signal in a project tutorial character : sprint. Address doesn't help us much. And it says line 36. Let's check out what line 36 is. Maybe it was line 136. It was line 136, I think. Get character movement. Oh, interesting. Is there possibly a way where we somehow removed, destroyed, damaged, disrupted the character movement component? Because that would result in WASD not working, and it would result in crashing when we tried to do character movement. So sometimes crashes can honestly be a banger. Yeah, we somehow. So let's just test that again, just to test that theory. If the character movement component is gone, if we compile and then we run, then we can check if our. Okay, it just crashed when I tried to break my mouse free. Well, I'll check again. Maybe, because I hit shift while I was pressing the shortcut for that. So that suggests confirmation of our theory. Good. Okay, so let's play the game. We're already playing the game. Let's look for BP first person character. Go to details. It's empty. Completely empty. And that would be why nothing is happening. Something that we're doing is somehow destroying the entire inner workings of our character, just completely annihilating them. So that's fun. And we're not messing with the tick function anymore. So something has got to change. Okay, this is where it would be helpful if we had version control hooked up, because we could just roll back a couple versions, see what happens. But yeah, let's. When I can't remember when the last time that we were testing it that it worked either. So who knows which of these changes are okay and which ones aren't. Which is, yeah, it's kind of an awkward place to be. This can sometimes happen if you make too many changes at once. It's really hard to figure out which change caused a problem. So yeah, basically we need to figure out what caused the problem before we can fix it. And we're just completely. Okay, so let's check if it's the blueprint or the C++ class that's causing this issue. Now, the way we can do that is if we right click, we can add a new blueprint class based on our custom class. If we search for a character, we can make a blueprint based on our tutorial project character class. And then it'll be the sort of a sibling of BP first person character. And if it's also gets messed up, we know it's the C++ file. If it's not, then we know it's somewhere in the blueprint file. Let's open it up just to make sure that if there's any like movement speed or anything that we make sure that we have it at not 0 so that we don't just get the same problem again somehow. Okay, and then if we go into world settings, if it's not open, you can open it by clicking on the map up here. So the overall item here is the map, which has the same name as the map. And then we can go to game mode, default pawn class, and we're going to change it to BP character test, which is the character we just created. Now if we play, it's using BP character test instead. Okay, character test doesn't have the inputs set up. Let's search for input. Jump action, jump. Move action, move. Sprint action, sprint. Crouch action, crouch. And look action, look. So hopefully that's mostly what we need to do to add that. The shortcut for play, by the way, is Option P, and we have movement. So we did something in our blueprint which ruined our BP first person character. Something we did here ruined it. It's not in the script, so we can in fact uncomment these lines. Command / is the shortcut for commenting or uncommenting, so you can comment uncomment with that. And it doesn't work with these multi-line comments. It only works with single, like the / comments, which it adds or subtracts. So let's compile that. Still using our test character, so we can see, do any of those break it? Do those work? Are we good to go? And we still have all of the components, even if they're not filled out, like our mesh isn't filled out with a mesh like it is in the default BP first person character. But it's still there, so we can still access all of our components. We don't have to worry about that. Okay, so pressing crouch. Pressing crouch does not do anything. Pressing crouch does not even slow us down, I don't believe. So this is moving forward. Sprinting, letting go of sprint, back to normal. Pressing crouch, yeah, pressing crouch isn't doing anything at the moment. Let's hop back over and get crouching working. And then maybe later down the line we can try to fix whatever is going on with crouch. Okay, we're still getting an error for tick. I think that's a mistake on Visual Studio Code's part, because we have tick here, delta time, all good. See, I think that's on Visual Studio Code's part. I think they have a mistake there. Hopefully that's the case. So yeah, start crouch and stop crouch, setting the max walk speed and the desired standing amount, and we aren't seeing anything happening there. So let's just double check and make sure for character test we have crouch action enabled here, and it is applied there. So let's see what happens with the movement speed, just to check in our little details. Switch to details panel, first person character, is that the right one? Oh no, first person test, yes. Character test, sorry. So we have character movement, search for speed. Okay, now if we go back into the game, walking, sprinting increases it to 900. Tapping crouch does not do anything to it. So yeah, something obviously is still going wrong with that. We still have the B is crouched, stop crouch, start crouch. So once again, we're going to be printing. I believe I remember to compile everything this time, but obviously we can check that. Yeah, it compiled super fast, so obviously we had already compiled. Okay, so now we're gonna add another attempt at a print statement, unless I missed uncommenting it, dang it. Missed uncommenting it, so obviously that's why it wasn't working. Save that, compile again. Yeah, that is the thing with commenting out a whole bunch of code. That happens. Even when sometimes the steps you take to debug a problem, even when you fix a problem, it's really hard to go back and to remember to go back and fix all of them. Okay, so crouch is now slowing the player, but I don't see any. Oh, we are moving down. It's just extremely slow. So if you're moving, you'll probably miss it. So obviously we want to speed that up. So let's add a. We could add a speed variable, but that's not very easy to work with. So let's instead add a time variable for how long it's going to take to go from one state, crouching, or walking, to the other state, walking or crouching. So we can just, once again, copy one of these, especially because they're a float variable, makes it super easy. And because they're already in the movement category, we want to say crouch transition time. And let's set it to 1 second. And then what we want to do is we want to, let's think about this. So currently, obviously, we are adding delta time or subtracting delta time. So we need to change the amount that we're adding or subtracting based on our variables. So we have 20. This has to go to 20 units. It has to change 20 units. So if we multiply this by 20 and then divide it by our, crouch transition time. Crouch transition time. Then we are effectively saying it will take 1 second to do that modification of 20 units. Right, so obviously right now it's 1, so it doesn't do anything, so we're just multiplying it by 20, and since it's a modification of 20 units, that's going to take 1 second. If this were 2, then we would divide it by 2, it would be half as fast, and so it would take 2 whole seconds. Now we're getting an error with crouch transition time. Just going to ignore it, see what happens. Like Visual Studio Code is, it goes through phases. Sometimes it's super fast at identifying which are errors and which are not. Sometimes it's not. I think maybe it like stores some information about other programs and what's going on, and sometimes that doesn't happen. But okay, so that's what I was saying earlier about how if you are close to the bottom of the range, you're close to fully crouched, and then you go over top of it, well, then you got to fix it. So you go back and forth, and it just does that jitter effect, which obviously we don't want to do. So the issue is we're adding here delta time times 20 divided by this, and here we're just checking delta time. So we need to check the whole thing, this whole thing. So let's create a variable for that. Since we're using it 1, 2, 3, 4 times, or we should be using it 4 times, we're not, which is why the error occurred. If we had already had a variable for this, the error wouldn't have occurred. So that's why we want to create a float transition amount, and then we'll set that to delta time times 20 divided by crouch transition time, and then we can just go ahead and put transition amount in here. We're adding it here, plus equaling it here, adding it here, and subtracting it here. Sorry, subtracting on both of these. And if we'd already had a variable covering these 4 spots, then when we added the times 20 divided by crouch transition time, it would have been taken care of. Although I guess it was just delta time, so we didn't really need it, but it does make it more explicit what's going on here. And yeah, sometimes that's worth it because the compiler will optimize that variable name out of the mix. So honestly, it's basically like a comment saying what you're doing, that variable name. So if you need to use a variable name to make it clear what's going on to your future self or to programmers who are working with you, I didn't need to compile that again. You can, you can absolutely name a variable for that. Okay, so it's a little bit fast. It also doesn't go very low, so I feel like we should change how low we're going to. So we change it to, so we're going down to 20, and then obviously we need to change the range to 40. Compile that. We should obviously probably expose those as variables for uncrouched height and crouched height. Could be a good thing. Also, yeah, maybe we could increase the uncrouched height to make more of a dramatic difference. But okay, so it's still just it's so fast that it just feels almost like a snap. Honestly, I mean that could be fine. Let's also check, and we also need to add the capsule, obviously. So before we fine tune the variables, let's go ahead and add the capsule. We're going to be doing basically the same thing, but we are going to be adjusting. We're going to be adjusting the scale or something like that here. Input. Okay, so capsule component. We're going to be adjusting the capsule half height here. So you can see it starts out at 96, and then we're gonna adjust it down to maybe like 72. And we could make these match up more. So 60, if we go down 96 down to 72, that's a quarter. We're chopping off a quarter. So we could have 45 and 15. We could have it only go down from 60 down 1/4 to 45. And then we could have the capsule also go down 1/4. So I think having both of them go down 1/4 could be a good idea. Could also not be. We can adjust it later. So we want to say okay, so we're basically just doing the same thing as here. We need to get the capsule component. Get capsule component. Once again, this is a function from I think the character class. So this is a function that's built in. The capsule component is in the character class, but it's private, so we have to use this function to access it. We say get capsule component, set half height, set capsule half height, and then we just want to set this capsule half height to 72 plus 24 is the difference between 72 and 90, multiplied by the transition, not the transition amount, that's a local variable up there, which obviously we don't want to be using, times the current standing amount. So the base height is 72, and we'll add from 0 to 24 based on how much we're standing up. So I think that's just a simple one-liner to add that functionality in. Let's test it out. It seems suspiciously simple, but perhaps it just is that simple. We're about to find out. Play the game, walk a little bit, crouch, uncrouch, crouch. Okay, so now we need to check and see if the capsule is actually adjusting height. So if we go into our test character, we can, by default, it's hidden in game. There's a very, Boolean called hidden in game. And if we uncheck that, then it'll show up when we're playing the game. So you can see we have a little line in front of us. That's the capsule component that we're looking at. And obviously if we crouch, it'll look much the same. But if we use function or F8 or just F8 to escape, we can see, oh, that's a lot shorter. Function F8 back in just to make sure. Control again to uncrouch. Function F8 back, zoom out. Yeah, we can see it got a lot taller. So it's obviously changing height in between. And we can also test that, see if we can go under an obstacle. If we just grab one of these, you can hold down Option and drag to create a duplicate. And I think maybe somewhere around this height would be suitable. So you can see if we play, let's see if this is short enough. Oh, it is just short enough. I think that's the perfect height. So if we uncrouch, we walk into it, we bash our head into it. If we crouch, we're able to go under. So that's a perfect demo. We're able to crouch, uncrouch, crouch. Now obviously there may be some issues if you uncrouch while you're under it, then your head stabs into it and you are stuck. So that would be something to fix later down the line. There's also a couple of other things. So the sprinting and crouching mechanics don't interact quite properly. If we are sprinting and we tap crouch to crouch, it works perfectly. Then if we let go of sprint, we go back to regular speed. And the reason for that is when we let go of sprint, regardless of whether we're crouching or sprinting, we still call stop sprinting and we still, stop sprinting and we still set it to walk speed. So we need to add an additional check here that says if we're crouching, we should use crouch speed instead of walk speed. Is C++ better than Blueprints? That's a great question. Not exactly. C++ has more options, I would say. There's more stuff you can do because Blueprints are made on top of C++. So the blueprints will always have a subset of the functionality because the blueprints are made out of C++, so they can't have all the functionality of the thing that they're made out of. So it's kind of like if I'm trying to think of a good analogy and struggling, but let's say your goal is to make a suit of armor, right? You have C++, which is a big fat metal block. With this metal block, you can melt it down, you can make any kind of armor you want, right? You can make thick plate armor, you can make chainmail armor, you can make all these different types of armors. And then you have blueprints, which are metal that's already been hammered out into a nice thin sheet. So you can't make chainmail armor very well, because it's already in a thin sheet, but you can make plate armor much easier because it's already in a thin sheet, so you just have to cut it out and shape it and add straps, right? That was kind of a long-winded analogy, but the blueprints can be a lot easier to get into, especially for prototyping. Your thin metal sheet, you can quickly hammer out a couple shapes and test them out on yourself to see if they fit well and if it looks nice, right? Whereas the metal block, it would take forever to smelt it out into a thin sheet and then make the blocks. But if you want the best, most optimized AAA game ever, then you have to start from the ground up. You have to start from the metal block up and build a lot more stuff yourself. So what I usually do to bring this to something practical after a whole bunch of analogy is I prototype stuff in Blueprints, and then if it gets really good and I want to make a game out of it, I start from scratch in C++. I create the exact same thing in C++ because then it's just more I believe it's more performant, and it's just a lot more powerful doing it in C++. If you try to make a super complex thing in Blueprint, it often ends up like a big whole spaghetti thing. It's a meme at this point, how spaghetti it can get if you try to create a complex stuff in Blueprints. So I prefer looking at a 1,000-line code file than I would looking at the equivalent in Blueprint. I think it's easier to read. Some people, that might not be the case. If Blueprint works for you, there have been whole games that have done well, typically indie games, that have done super well that have been made only in Blueprint. I think, I can't think of one off the top of my head. There have been some, I know, that have been made wholly in Blueprint and have been perfectly viable games. There's no specific right way to do it. If you can make a banger game using just Blueprints, that's fine. But I find it easiest to maybe do a little bit of prototyping in Blueprints, then create the final core functionality in C++ and tune variables in Blueprints, obviously, because the compile time tuning variables in C++ is torture. So we need to add a check in stop sprinting so that if B is crouched, and what we're going to do here is we're going to use what's called a ternary operator, a fancy name. Basically, it's kind of like an if statement, but it's all in one line. So we say if B is crouched, then select crouch speed, because obviously if we're already crouched, then we want to switch from sprint speed not to walk speed but to crouch speed. Otherwise, that's what the colon is, switch to walk speed. So when we stop sprinting, if we're crouched, we're going to use crouch speed. If we're not crouched, we're going to use walk speed. That's it. And now if we compile, we should be rid of that bug. We can test it out, obviously. Okay. So the bug was sprinting, and then you tap crouch to crouch, and obviously you slow down, and then you let go of shift, stop sprinting, and it stays crouched. So yeah, there you go. Okay. Obviously there's lots more that we can do with this. The gun is currently somewhere up there. I think it's something. Maybe it's, oh, the gun actually just isn't doing anything because we're in the character test right now and not the BP first person character. So somehow I screwed up this blueprint. Obviously we could spend time fixing that, but I don't think that's, I don't think we're going to do that tonight because it's already almost 2 hours and I'm trying to keep these live streams from being too long. So yeah, we have a sprint system and a crouch system, and they both work really well together. The crouch system not only slows us down, we have three variables that we can use to change the 3 different speeds. We have like a whole movement section that we added for sprint speed, walk speed, crouch speed, how long it transitions between those. We can make the transition super short if we wanted to. And we have a couple of added input components that we added to allow us to sprint and crouch, and the crouching even lowers our collision so that whereas we couldn't walk into this normally if we're crouching, then we could. So yeah, we have a pretty robust crouching and sprinting system, and I think it's I think that's a pretty good beginner tutorial for how to install Unreal and how to do a couple basic things with it. Let me know if you're watching this live right now. Go ahead and throw any questions at me. But if you're not, let me know in the comments like what you'd like to see for next week's live stream, because we're probably going to be diving more into Unreal and creating some more cool stuff in Unreal. As I said, with these tutorials, we are working towards actually creating a game with Unreal, but we are obviously starting with just some basic tutorials, and once we've gotten through enough of that, we will move on to actually creating a game. So any questions, I'll go ahead and hold on for those, but it doesn't look like there are going to be any. So thank you all for watching. Don't forget to subscribe, whatever. that was going to be a nice smooth ending, right? But the end stream button isn't instant. It pops up a notification and then I have to click end on that. So there will not be a smooth ending on this